Now, looking at this question displayed to you, the front of the screen, we want to see how we can find the value of k on this expression. But first, looking at this question, I want us to interpret something which will be easier for us to get the values of k. There are two things that are involved here. The first thing is the fact that they're asking us to look for the values of k from that expression. And looking at that expression, they have specifically told us that the roots of the equation are equal. Now, looking at the interpretation of the question, if the root of an equation is equal, this simply means that the discriminant b squared minus 4ac must be equal to 0. In other words, we need to equate b squared minus 4ac equal to 0 and start to fit in the various proportionate according to the expression b squared minus 4ac equals to 0. And looking at that expression, you're going to see that it is easy for us to see b, it is easy for us to see a, and the constant c, which we can just use and fit in inside of the b squared minus 4ac equal to 0. When we do that, we are now going to see how we can collect the like terms together and see how we can form the expression to easily get the value of k, which of course we are going to have two values. Let's now look at that interpretation and try to solve this question together. Let's now proceed to the solving of the question. Let's proceed. We have this question before us. Find the values of the constant k for which the root of the equation x squared minus 2 in bracket 1 plus 3k x plus 7 in bracket 2k plus 3 is equal to 0 are equal. So they are asking us to look for values of k for this particular expression. So looking at this particular question, the first thing we want to look at is the fact that they have given us this expression, as you can see here. Then they say is equal to 0 are equal. Now, for us, there is something you need to know. If the roots of the equation are to be equal, then the discriminant b squared minus 4ac must be equal to 0. That's the first step we need to use to approach this question. If at all it should be equal, then the discriminant b squared minus 4ac must be equal to 0. In other words, b squared minus 4ac must be equal to 0. Now, based on the expression, we need to therefore arrange the b squared, the a and the c, so that we know exactly how to express them. First, looking at a here is equal to the coefficient of x squared is a. For if we still use the expression like ax squared plus bx plus c is equal to 0, the a, which is the coefficient of the x squared here, is equal to 1. The b is equal to, which is the one in front of the x, you can see this is the one here in front of the x, is minus 2 in bracket 1 plus 3k, which is minus 2 in bracket 1 plus 3k, and the c, which you can see here is the constant, is all of these, and the c is equal to 7 into 2k plus 3. So now we have already arranged the a, the b, and the c. And since we have said that if the roots are equal, then the discriminant b squared minus 4ac must be equal to 0, then we now need to fit the b squared minus 4ac and equate it to 0. In this case, what we are going to do is to take b of square. Our b here is minus 2 into 1 plus 3k all square. So we are going to say minus 2 into 1 plus 3k. All need to be square, minus 4 into a is 1, into c is 7 into 2k plus 3, 7 into 2k, plus 3 and equate it to 0. That's the simplest expression based on what we have here. So this is what we have. We need to now express this and put it in one side. We need to arrange, as you can see here. Now, assuming that we are here at this position, where we have tried to express everything, as you can see, by using a, b, and c and putting it in the expression of the b squared minus 4ac equal to 0, let's now try to see how we can express this. Since it is a square, let's express this. Square means 2 times, and rearrange this again to make sure that they form that particular expression for us to look for the values of k. Beginning at that, this square simply means rewrite minus 2 into 1 plus 3 of k, then minus 2 into 1 plus 3k, that is twice. This simply means that we can still say minus 2 into 1 plus 3k into minus 2 into 1 plus 3k. It is the square which we have just expressed here, and we can just say minus 4 into 1, that is 7 into 2k plus 3 is equal to 0. So that is the expression of the square. Now, all of these, as you can see, since as this expression of the square, this and this, then still note that since it is like this, it is all like this. Then we can take one of the term here, or just rewrite this again and form this one, then form this and still make it to be an expression of a multiple, or to make it as if it is still a square, because these are 2 separate brackets. Now let's look at the first one. Minus 2 times 1 is going to give us minus 2. Minus 2 times plus 3k is going to give us minus 6k. Let's rewrite the bracket again. Let's come and write this bracket as well. Minus 2 into this, they give us minus 2. Minus 2 times plus 3, minus 6k. So this is just what we have again. Now it is still here, we have rearranged. Let's rewrite this again. Minus 4 into 1. So 7 times 2k, let's put it in the bracket, as you can see, 14k plus 7 times 3 is 21 is equal to 0. Now, this, which is still a square, simply means take one of the term that is here and express with all of the term here, then the next term and express with all of the term. We are going to do that. So minus 2 and express with all of the term of this, which is minus 2 minus 6k. Then the next term here is minus 6k. So minus 6k into all of the term here, minus 2 minus 6k. Then we rearrange this again, which is minus 4 times 1 is just the minus 4 into 14k plus 21 is equal to 0. Let's now try to express this. Minus 2 times minus 2 is plus 4. Minus 2 times minus 6k is plus 12k. Plus 12k. Minus 6k times minus 2, it is plus 12k again. Minus 6k times minus 6k is plus 36k square. Then let's re-add this. Minus 4 times 14k is going to give us minus 56k. Minus 56k. Minus 4 times plus 21 is going to give us minus 84. Is going to be equal to 0. We now have this expression. Let's rearrange. we have plus, that is 4. 12k plus 12k is plus 24k. You can see plus 36k square minus 56k minus 84 is equal to 0. So let's try to look at something here. We have minus 56k and 24k. So like terms, let's try to add these two. Minus 56k plus 24k is going to give us minus 32k. And this is 36k square. Since it is the k square that is beginning, as you can see based on our expression, which we stated here, ax square plus bx plus c is equal to 0. Let's try to begin with the k square. Let's bring this at the start, which is, let's try to bring this here at the start, 36k square, 36k square. Then now the next, which is the x, like the x in it, which is, we are going to rearrange this one. Minus 56k plus 24k is going to give us minus 32k. Now let's put the constant. Minus 84 plus 4 is minus 80 is equal to 0. Now we have arranged that. And now let's look now for the value of k. You can see k is now showing very clearly. It is now to look for the value of k right now. And if we looked at that, let's look at what could go throughout that. If we divide all the side by 4, because 4 is common to all of them, as you can see here, since as 4 is common, let's try to divide all the side by 4, because 4 is common to all of them. So if we say this divided by 4, we're also going to say divided by 4, we're also going to say divided by 4 to bring it to the lowest term. And if we take 36 divided by 4, since 4 is common, we are going to have 9k square. 32 divided by 4, we are going to have minus 32 divided by 4 is 8k. Then we are going to have 80 divided by 4. We are going to have 20, that is minus 20, will be equal to 0. We now have this. Let's look at what we can do more from this point. If we try to factorize, we are going to see that if we factorize, it is possible by using this particular formula that states that we look for the term that's going to go here and look for the other one that is going to go here and give us the center. And if there is any common term, then we use it as a factor. For example, we are going to use the expression 9 and 1, that is 9k and 1k, to still give us 9 times 1 is still 9, that is 9k times 1 will give us 9k square, which is still here. Let's try to express this one into two parts in a way that if we cross multiply here, we are going to get the center, which is minus 8k. Let's see which is possible. 10 is possible and minus 2. Because 10 times minus 2, as you can see here, 10 times minus 2 will give us minus 20. Now if we cross multiply like this and say 9 times minus 2 is going to give us 18k. 18k minus 10 times k will give us minus 8. Let's try it here. 9 times minus 2 is going to give us minus 18. That is minus 18k. Then plus, let's take this side now, 10 times k, 10k. If this expression is able to give us this center, then the factor will be correct. Minus 18k plus 10 is going to give us minus 8, which is equal to minus 8k. So it has given us this one, which means that this factor are correct. Which means that 9k plus 10 and 1k minus 2 is the factor. So we have two factors here. One of the factor is 9k plus 10 will be equal to 0, and as well as k minus 2 will be equal to 0, since it is already factor. So now if k minus 2 is equal to 0 and 9k plus 10 is equal to 0, then we can easily have the value of k from these two expressions. Now k minus 2 is equal to 0, minus 2 is equal to 0. This implies that the value of k here is equal to plus 2. That is one of the value of k. It is plus 2. Now let's look at this. When 9k plus 10 is equal to 0, this will imply that 9k plus 10 is equal to 0. Therefore, 9k is equal to minus 10. If we carry the 10 there, then k will be equal to minus 10 over 9, which is going to give us a negative value, minus 10 over 9. As fraction, as you can see, we are going to have a small fraction. So those are the values of k. K is a positive 2 or 2, and k is minus 9 over 10. So that is the values. Those are the values of k based on this particular expression that has been given us. For us to look or find the values of k in the expression that has been given, as you can see here, being that the roots are equal. So this is how we can solve this expression easily based on what we have shared with you. And to those of you who want to be seeing more questions like this, based on other related topics as well as this particular topic, and more topics when it concerns this idea of math solving based on different levels, then of course you want to make sure to go ahead to subscribe to this channel so that every time we publish or post a new video, you're going to get notified and see how you can learn some of the tips and tricks we have to share with you. Of course, you also want to make sure to go ahead to enable the notification bell icon so that once we publish a video, you have notification and watch it to learn something new all the time. See you again in the next upload, and bye-bye for now.